So, what we've done so far is we have talked about a frequency distribution, and that's a great way to understand data. But sometimes frequency distributions kind of hide information in all the numbers. And so often what we'll do is we'll turn that frequency distribution into a graph called a histogram. And so this video is about histograms, the definition of which a histogram is essentially a bar graph where the bars have equal width and the heights represent and the heights represent the frequency, and that, wow, that's really bad writing. Anyway, represent the frequency, and that frequency could be written as numbers. It could be written as percentages or a relative frequency, or it could even be written as a probability, which is another way to talk about a percentage. And so histograms have that kind of look, and it's really nice. All right. And so let's take a peek at what we're looking at and how we put class widths and frequencies in the graph. So the uses of a histogram is, number one, it's a visual display of the distribution of the data. What categories are the numbers in the data. It very often will show where the center of the data is located. It will also show how spread out the data is, visually speaking, and it can be helpful in identifying what we're going to call our outliers. And so we'll define these things in a moment, but let's take a look at that. All right, so here we go. So yesterday we completed a frequency distribution for the ages of presidents. And I'm going to work through creating this frequency distribution again, just so we can remember how we did it. So the age classes, we were supposed to start at 40 for the ages of presidents and have a class width of 5. That means the lower limit of each group is 5 more than the previous one. And then the upper limit is 1 less than the lower class limit of the next one. So this would be 44, 49, 54, 59, 64, 69, 74. And then the next thing we do is we count or tally the amounts in each class. Now, another way to do this is, I showed you on the calculator how to order things, or you could do that in Excel. But another way to do this so you don't skip data is just put a mark in each class for each piece of data. And so that's what I'm doing right now. And so you just keep track of each piece of data by putting a mark for that piece of data. All right. And I'm going to continue to do this, and I'll be right back. Okay, I have finished the frequency table right there. And as you can see, I made the tally marks and that's a good way to organize, go through the data and then make sure you don't miss the data as well as putting them in order. So that's just a way to do it completely by hand without ordering the data with technology. These were the frequencies we had, and what we want to do now is we want to make what's called a frequency histogram. Okay? Now, to do this frequency histogram, we need to find the class boundaries. And if you remember, the class boundaries are the lower class limit. Let me grab a different color. The lower class limit of a class averaged with the upper limit of the previous class. And so our class boundaries, I'm going to write them down. You can usually figure this out pretty quick. Our class boundaries are going to be, sorry about that, are going to be 39.5, 44.5, 49.5, 54.5, 59.5, 64.5, 69.5, and 74.5. So those are our class boundaries. Now, and all I've done is I've added these two together in each group and divided by 2, and I got those. Or I found halfway between them, however you wish to kind of think about that. Now, once you have the class boundaries, you can start to create the graph. And so one of the things we do in a graph is to indicate that we're not starting at 0 is we make a mark like that, okay? That indicates we're not starting at 0. And my classes represent age of president in years, okay? So I want to label my x-axis, and then my y-axis, I also want to label it frequency, and it's okay with me if you use abbreviations, but they should be common abbreviations. And now what we do is on the x-axis, we just place our class boundaries. So 39.5, 44.5, 49.5, 54.5, 59.5, 64.5, 69.5, and 74.5. All right? So, okay. So I could label these axes the rest of the way out, all the way to 74.5. So I'll just put ... here to indicate the continuing. In general, you would label all of those. Now, here's the key thing about histograms. The height of the histograms match the frequencies. Now notice these frequencies over here go from 1 up to 10. So I need to mark my numbers equivalently. So I might do like 5 to 10, and then I'll do 1, 2, 3, 4, 5. So it's equal 6, 7, 8, 9, 10. So I need those frequencies to be equal. Again, I could label all of them, or I can label a few of them so it's apparent what the pattern is. At this point, the histogram, the bars touch each other. Notice that our bars are all the class width of 5, 39.5 to 44.5, that width. And so that corresponds to a frequency of 2. So that's the maximum, and there's the bar, okay? And then the next bar is 7. Okay, 6, 7 is right there. And so there's 7. And the next bar would be 10. And then the next class is 54.5 to 59.5. And that would also be 10. And then the next bar is 6. Height right there. Hopefully the colors help you see it a little better. And the next bar would be 3. All right, and finally the last bar would be 1. Now, sometimes you'll have a class that is not does not have any frequency, any data at all in the class. And so it helps you find missing data. Sometimes you'll have a class, let's say both Trump and Joe Biden, well, especially Joe Biden, because he's like, 82 or 83 right now. So Joe Biden, if he was in this data and there wasn't a Trump, let's say, because Joe Biden's the oldest president we've ever had, he would be out, he might be out here a whole nother class. And, if somebody was really old, that might look like an outlier. And so we might consider that, especially if he was like 85 or something, which he might be. He was pretty old. Anyway, I forget his age, but it might look like that. We don't have that in this case, so it's not there. And so I don't worry about it. But in general, we can see this distribution. Now, because of the way the distribution looks, we can visualize how many are in each category by the height of the bars, and even begin to say, oh, there were 10 presidents from 49.5 to 54.5 years. And so that's why it's often good to go ahead and label this axis for sure. All the class widths are equal. That's a nice feature, and we'll see what that's like later. We could visualize the center of this really easily. The center, it looks like, it's going to be right about here, right around 54.5 years old. We can kind of visualize it. About half the data is on one side and half the data is on the other. So seeing the center is a really good possibility. It could be slightly a little bit more over. We can see how spread out the data is. We see it spreads from essentially 39.5 years to 74.5 years. If we go back to the frequency table, we can see that that's really 40 to 74. Now, the truth is the actual ages, the younger president ages were actually 42. So you'd have to go back to the original data to get the exact information. So notice how we go from data to table to histogram, how we lose information, but we also gain perspective. We can see the whole spread as a visual. We can see the center. We can see that there are no outliers. There's no unusually aged president, a 90-year-old president. So there are a lot of features that we gain by making the picture, but there are features of the exact data that we lose as we work our way to here. So when you start to critically think about these, this kind of thing you want to think about. Okay, just to review, to create a histogram, you need the class width, you need the upper and lower class boundaries, not the limits, but the boundaries, okay? And then you put these on the x-axis, and then you need to know the frequencies in the categories, and those you put on the y-axis, and then you draw your bars based on that. Oh, I would also say label axes, okay? Now, one other thing we're going to do really quick, let me shrink this just a little more. One other thing we'll do really quick is we're going to do a relative frequency histogram. The only difference here is, if you remember, a relative frequency is where you convert the data to a percentage, to a fraction or percentage or a decimal. And in this case, there are 39 presidents listed in terms of ages. So you have to divide each number by 39. So 2 divided by 39 is actually 5.1%. Okay. 7 divided by 39 is actually 17.9%. 10 divided by 39 is 25.6%. 25.6. And 6 divided by 39 is 15.4. Now I'm rounding these, of course. 3 divided by 39 is 7.7. And 1 divided by 39 is 2.6. Okay? And so the difference is, now you have percentages. Now notice our percentages go from about 2% up to 26%. So how do I label this? So I do the same thing. I do 39.5, 44.5, 49.5, etc. Okay? I label this. I put the label, what do these numbers represent? I put the label, what do these represent? So now, instead of putting frequency here, we would put, big difference, we would put relative frequency. And then what we would do is list percentages. So I would have like 5%, 10%, 15%, etc. on up the graph and go to 30% probably. That's how I would do it. And then I would look at my table, and my table here, 5.1%. So the first bar is really close to 5%, and I would draw that bar like that, okay? Now the next bar is 17.9%, all the way up to like about 18%. So that bar would be there, okay? And then the next bar is up to almost 26%. So you go 20, 25. So it would be right about there. And again, these bars all have the same width, etc. So that would be a relative frequency histogram. Now, the key thing about this relative frequency histogram is, even though you've done it in percentages, the way it looks is not any different. Okay? It will look just like this graph, except these will be labeled as a percentage. Okay? So that is how you create a relative frequency histogram. Let's look at a couple of the other data things. So there are a couple of things about histograms that we need to think about. First of all, we definitely always need to think about the center. Okay, now the center can vary where it's located, and I'll talk about that when we look at a few things here in just a moment. The other things we talk about, one of them is variation. Variation is really another word for spread. Okay. We also want to talk about the idea of the shape. What does this histogram look like? What's its shape? That can tell us things. And then we also like to talk about if there are outliers. All right. And then sometimes we like to talk about time if it happens to be a time series graph. And we will look at those later when we look at data over time. So that's not going to show up here too much at the beginning. All right. So the first thing I want to say is let's talk about shape first. There are actually four shapes that whenever we are asked, what's the shape of this graph or the shape of this data or the shape of the distribution, there are four shapes. There is what we call symmetric, which eventually we're going to give the name normal to. There is what's called skewed, and you can be skewed left or you can be skewed right. We'll talk about what that means. Okay. So there's two more right there, skewed left, skewed right. And there can be what's called uniform. All right. There are other things, but these are the main shapes that we talk about. So what does a symmetric distribution look like? All right, let's put this up here. What does a symmetric distribution look like? Well, a symmetric distribution looks like this. Has this kind of a shape. It's high in the middle and it's really low on the ends. And so it has that shape. Now, if you think about our president histogram we just made, it was fairly symmetric. Now, it wasn't perfect, but it was pretty close. Looked something like that. And it just gave us a sense of it being really even. If it's symmetric, then the center is going to be really close to the middle. Okay? And that makes sense as well. And its spread, its variation, it's going to have an equal amount of spread or an equal amount of data on both sides. So it's going to vary in kind of a really nice way. All right? Now, a uniform distribution basically would have a rectangle shape. So when you look at the histogram, all the histograms are really close to the same size. And so what this looks like is it just looks like a rectangle. If you have that sort of situation, it's uniform. Now, in uniform distributions, the center is close to the middle of the rectangle, the big rectangle. The spread, the data is equal on either side. Both of these have no outliers. No outliers. Because we don't see anything unusual with the shape. The spread's fairly equal on both sides. Okay? And so that really helps us with uniform. So what is skewed? So the textbook actually gives a great hint of this on page 57. And it asks you to look at your feet. All right? If you look at your left foot, you get this sort of look. And if you look at your right foot, you get this sort of look. Well, this is called skewed left, and this is called skewed right. Okay? The reality is it looks like this. Skewed left has a tail to the left, all right? And skewed right has a long stretched out tail to the right. Okay? So skewed left and right. So what happens here? Well, because this has lower data values, it'll tend to lower the average from the peak a little bit. So the center is going to be a little to the left of the peak. On skewed right, the center is going to be a little to the right of the peak. For the same reason, these values over here tend to pull it up, okay? The shapes are skewed, all right? The spread, well, they tend to be more spread out on the left and more bunched up on the right in skewed left, and then vice versa in skewed right, more bunched up on the left and more spread out on the right, okay? And so you want to keep those straight. Now, if you're skewed left or skewed right, there may be outliers, all right? And that's because you might have a data value way over here on skewed left or way over here on skewed right. And there'll be a way for us to determine if that's an actual outlier or not. So this is a way to think about distributions and the common shapes of distributions. A problem right now, and that problem is number 15 on page 53. And for this problem, I'm going to show you how to create a histogram, and you do a normal quantile plot, and then on a calculator, and so you can kind of check your work. I think it's actually faster to do some of these things by hand, but the normal quantile plot you can't do by hand very easily, so it's much easier on the calculator, and for that you need the histogram. Okay, so let's get to it. So the first thing I did is I went stat, edit, and then I entered all the data from column 15. Now there's a lot of it, so you got to make sure it's correct. And that's one of the first things you have to do is edit to make sure you got it all. There were 50 data points. I got all 50 of them, and I entered those, so they're all there. So now the next thing you do is you want to use right here above the y equals button is something called plot. That is for statistics. So you can access it by doing second plot. Now, as you see, you have some menus here. The first thing I want to do is turn it on. I can make it a color, any color I wish. I tend to like blue. It's pretty noticeable. I can see it really well. And then the histogram is this third graph right here. That's the histogram. So now it says frequency. My frequencies are not in a list. My frequencies are just one each. Each data point is listed once. Even though some data, like 245, there are 4 of them, they're all just listed once in my table. So that's why the frequency is 1. If I had a 2-column table where it was a frequency table and the frequencies were in the second column, then I would say the frequency is list 2. And then my data is in list 1. And if you look, list 1, list 2, list 3, list 4, list 5, list 6 are above the keys on this calculator. Once you have all that information, you can press enter I believe, or excuse me, enter on the calculator. Oh, no. At that point, you want a graph. Now, typically what people do is I'm sorry, not press enter, you want to press graph. Wait a second, I do not see this. And then I think, oh, my X values are in the 200s. So is it over there in the 200s at 125? Do I have the data show up? Oh, there it is. And so I notice that what I have to do is if I'm going to make this histogram, they did it for single data. They just did a bar graph for single data, and this is what they got. Um, so there's more that I can do. Now, one of the things I used to be able to do, and I want to show you this, is you could do something called zoom stat, and it'll grab the data and it'll use that data to put it right there on your screen. So that's a nice feature, zoom stat. But now you can see it on my screen, but it's not organized very well. And I don't like single points being my histogram. So to fix that, now when I did zoom stat, it put the minimum at 125 and the max was 264, and it put those. So what I'm going to do is I'm going to organize it a little better. And I'll tell you why as we go along. So I'm going to make the X minimum 120 so I can see that on the screen. In fact, I'm going to go all the way back to 110. And I'll tell you why in a minute. And then the maximum value was 264, so I'll make my maximum 280. Now, basically, my data is between 120 and 270. Now, the most important thing for a histogram is the scale. Now, you can choose the scale. If I leave it at 1, it's going to make the data points show up. Each bar is going to be worth 1. But if I make it 10, it's going to make the width, it's going to make my class width 10. So the X scale for a histogram is class width. And I think 10 or 20 are pretty good choices. I actually like 10. Now, for the minimum Y, the smallest value I'm going to have is 0. And the maximum value I didn't count for each group of 10, but I have done this before. I think 25 is high enough. Now the Y scales I'm going to scale by 1 because that's the frequency, right? So 1 is perfectly fine there. Unless this is a bigger range, then I might scale it by 5 or 10s. Resolution doesn't matter. Delta X is auto, trace steps auto, so we're good there. So now we press graph. We'll recreate the graph, and doesn't that look like a much nicer histogram? Now, what I want you to notice, see how these are blended with the numbers on the bottom? That's kind of bad. So what I'll do is I'll go back, and the way I fix that is my Y minimum. So I'll put like -5, and that'll just move the graph up a little. I can see that horizontal axis clearly. And so this is a really good histogram. It's got about 7 or 8 bars, which is good. Typically you want between 5 and 20 bars. That's why I didn't like the single one. It had way more than 20 bars. If you change the class width, say I make it 5 for the class, pretty good one too. I kind of see a good picture of the graph as well. In this case, I have 3, 6, 9, 10, 11, 12 bars, and that's pretty good as well. And so I can change the view, and just one more. Suppose I had picked 20 for my class width. I have 5, which is okay, but it's not as clear to me. I kind of like the either with the class width of 5 or 10. For this problem, 10 to give me the... So now I have a nice view at this point, and what I want to do then is one more thing in the window. Good. So now I can see the data and I can describe this distribution. If I were to ignore this 125 value and the two values around 200, this would look fairly symmetric. But because those values are in there, I would say this distribution is skewed left. Okay? Now, I want to know, and if you just kind of follow me as I make this drawing, this is like your big toe on your left foot, and then these are like your little toes stretched out to the side. So that's like skewed left. Now, I want to kind of make sure on that, but that's how I can get a histogram. So the next thing I want to do is create a normal quantile plot, and I want to make sure and decide, is this data symmetric or is it really skewed left? So what I'm going to do is I'm going to go back to, I'm going to change it to this last graph here, which is the normal quantile plot. My data is in list 1, and my data axis, I just want it to be the x-axis. So everything else can stay the same. I can go ahead and I can see my normal quantile plot is there, but I don't like the way it looks so far. Notice how it kind of runs between -5 and 5. So I'm going to change that on the window. I'm going to make -5, and the y maximum I'm going to make 5. The rest, everything else is just fine. Now I get a good clear picture of my normal quantile plot. Now, as you see, here's the data point 125 over here. Here are the data points that were close to 205, I think 203 and 204. Here are a couple of other data points right here. But what I want you to look at is all these data points that are lined up in a line. Now, generally, if I have a normal curve, the data will be lined up in a line like this. So all that data on the right, if you remember, kind of looked like a symmetric distribution or normal all by itself. But, and you can see that because the normal quantile plot makes kind of a straight line here. It's not perfect, but very close. But if there is another line, which it looks like there is, if I grab from here and I run all the way to this point here, that looks like a completely different line. And if you end up with something like that in a normal quantile plot, that tells you your data is either skewed left or skewed right. If it was skewed right, the other line would be up here. And so my data is probably definitely skewed left. It's not symmetric, therefore it's not normal data. And that's what I wanted to show you on the calculators, how to do those two things. That's it. Thanks. That's it. Thanks. And that's it for the video. Hopefully that helps. Talk to you. See you in class. Bye.